It is actually my fault. All right. Okay, so here's what we're going to do today. We are going to talk about the different three-dimensional objects. The goal today is to do an introduction to the vocab terms. So no crazy formulas, nothing like that. It is just to go through some names. That's all I want to do. Super easy. I know I'll have you guys tomorrow for like 20 minutes tomorrow, something like that. We're just going to do a couple easy things tomorrow. That's it. Like, we're not going to get homework. We're not doing anything like that. I'm not going to assign anything. It's just one of those things that I just want to make sure we go through a couple things so we're not just wasting your time. All right, so three-dimensional figures. Let's kind of go through some names here. And can you hit the lights for me, please? Thank you. Okay, so three-dimensional figures. Thank you again. All right. There's different types. So what most people don't know is when we go to three-dimensional objects, there's a name for that. The most common name that we use for three-dimensional objects, certain types of three-dimensional objects, are called the polyhedron. Okay? And that's the first definition I want to go through today. Now, I'm not going to give you the definition right now. Remember, this is the outline screen. This will give you the words I want to go through today. So, polyhedra or polyhedron. Polyhedra is plural. Hedron is singular, that type of thing. So, okay. So, polyhedra, that is the shape that most people think of for the three-dimensional objects. We'll go through all the different names of them today. The ones you should know anyway. The second thing we're going to do is we're going to talk about the vocab that apply to the polyhedron. Okay, a simple shape, right? So one of the words we're going to talk about is called a face. That's the actual walls. So like this room is considered a polyhedron. It has faces. It has walls. Okay. Now other terms we're going to talk about is obviously edge and a vertex. Because we apply those to every shape. Right? They have edges, they have lines, they have points where the lines meet. Those are called vertices, a vertex. Okay, so these are the main terms I want to discuss today. Next thing, after we've talked about those, we have to go into the more specific types of shapes, like for instance a prism. Prisms are types of polyhedron, they're very specific looking ones. We have to go into the pyramids. Pyramids are types of polyhedron. They're just very specific looks to them. Okay? So these will be a part of the naming system when we get to these. I'll explain the concept, like the definition, so you know. That's pretty much the main goal there. Now, we have other things we can talk about. One of the other major bullets with prisms and pyramids is the curved edges, which are cylinders, cones, spheres. Like those are the conics. Most people think of like, okay, because I showed you circle the other day. Some people like think of three-dimensional objects, they think of the curves. I'll show you those names as well. And last but not least, after we talked about all those, you know, those conic sections, those curved edges, we are going to talk about what they call the regular polyhedra. Okay, the regular polyhedra is the most special type of polyhedron you can give you. If you think back to the word regular, we introduced that word yesterday. Regular means all the walls are the same and all the angles are the same. These are the most specific types of polyhedra that you can draw. They're super difficult looking until you think about like an actual object that represents it. Now, there's other names for the regular polyhedra. They're also called the platonic solids. That's another term that you'll see in your textbook if you ever look. But those are the ones we're going to go through. Okay, questions. Now, this is not a perfect order. I'm not going in this order today. These are just the different words I'm going to bring up. Now, there's a couple other things we're going to talk about on Monday. Not tomorrow, but Monday. Monday, we're going to talk about volume and surface area. Those are the two I want to talk about on Monday. We'll actually get formulas and all that good stuff. Questions? Perfect. Okay, so again, surface area and volume we're going to do Monday. We're going to get to this part today. And you're thinking, whoa, that's a lot of stuff. It's in literally 3 more slides from now. And we're done. I just give you some names. Okay, are we good to go? Everyone's got it? Okay, let's jump right in. Let's talk about polyhedra. Let's go through the definition here. So a polyhedra, by definition, singular is polyhedron. So I'm going to zoom in here so it's easier to see. These words are really small. Maybe it's just me. They look small. All right. Yeah, that'll work. Okay, polyhedron. It is a geometric figure. It's a solid that has flat surfaces, right? Flat surfaces on the walls. and it encloses a single region of space. So what I mean by that is, like, if you imagine that this room is a polyhedron, sorry, singular, polyhedron. You can definitely see that we have flat surfaces for walls, correct? Flat surfaces. And it is enclosing one area, one space. This is one classroom. I don't have like weird walls going down the middle of the room, kind of making it into different sections. It's one region of space. That's a polyhedron. I would not consider the school to be a polyhedron, because there's individual rooms in a school, but I would consider my classroom to be a polyhedron. Does that make sense? Okay, single region of space. Now, the actual objects themselves, because some people just want to look at it. What would it look like? Here's an example. Okay? This is an example of a polyhedron. Okay, it's got faces. Faces are the walls. So like in this room, the ceiling could be a face, the floor could be a face, this front marker board could be a face. The edges are where faces meet. It's like an actual line. You can actually see like the corner of the room. You can see a distinct line where the two walls meet. That's an edge. It's an actual line. And then a vertex is where those lines meet, those segments. Okay, does that make sense? Like the different terminology. Some people like to just see that picture. They like to see the labels. So if I start using these words, you'll understand what I'm talking about. Like what face is it? What, you know, how many edges are there? How many vertices are there? That type of thing. Okay, now let's get to those individual words. Let's talk about a face, right? A face is a flat surface. That's an individual definition. It is a flat surface. It's like a plane, right? Plane could be a flat surface for a polyhedron, right? The edges are those line segments connecting the faces. And then obviously the vertex is where multiple faces come together. And it's a point where three of the edges meet. Three edges meet to make a vertex for a polyhedron. Now, I showed you a picture there. I like to show different pictures so you can kind of get a glimpse of this. The picture I showed you is a pyramid, right? Pyramids go up to a singular point. Now, this is what most people always think of. And I think I even used these words the other day when we were talking about, because I talked about pyramids, what, was it yesterday or was it 2 days ago? Oh, when did we talk about pyramids? Was it yesterday? I don't remember. Days are blurring together. Some people refer to the bottom of a pyramid like a base. You're correct. I mean, that is a term we could use. It's the bottom, right? The base. But more importantly, it's a face, right? So base or face, I understand where you're coming from. Bases just happen to be usually the bottom of an object. But that's the idea. So if you ever use that word, you're not incorrect. It's just a different term we use. Okay. Questions on these basic terms. I try to highlight them in red, so if you're colorblind, I'm really sorry. They're highlighted in red. Face, edge, vertex. All right, now, one of the other things that this is the real mind trip here. I want you to think about this. Think about just an edge in general. An edge. Like edges are where the lines are. To draw an edge, and you know what an edge looks like. It's a segment, right? To draw an edge, you need two planes coming together to make that. Okay, you got your head wrapped around that? An edge takes two planes. But here's the weird thing. To draw an edge, you need 2 points and the line segment connects the 2 points, right? That's like the old school way we did it in chapter 1. 2 dots, draw a line, that's an edge. So you need 2 planes that make the edge, but an edge can make 2 dots. To make a single dot, a vertex, you need 3 planes coming together. You can see it. 3 planes, bottom, front, side. When 3 planes come together, they make a single dot. So when you start thinking of all these objects and how you make a dot and how you make an edge, there's multiple objects coming together to make that single object. That's the thing, like, what's the best way I can describe this? Where you really see the mathematics involved, like where things come together. Okay, imagine you're watching the movie Toy Story. How many people have actually seen like the bloopers for Toy Story? You ever watch like those weird special features, the bloopers? The bloopers are like those credits where they messed up somehow and like somebody, like the actor starts laughing, or the face of the cartoon character gets all like messed up because the math is failing. Like like where the eye suddenly like pokes out of the character's head and is like huge and there's like things coming all off of it, because they're trying to make a single object from 3 planes meeting, so it's in a very specific spot on that cartoon character's face, but computers are doing it and they can't get the math right, so it's lining up wrong. And so that's why the character's face is all blurry. It happens in video games. You play video games and a character's face isn't working right. It's because the math that's involved here. There's like a ton of math with like with digital imagery and video games and stuff, which you actually see like the idea of like when you're trying to like put these all together, it can be complicated. There's a lot more mathematics in those things than you actually think there are. Some people just think you're just designing and you're just, playing around, but there's actually tons of stuff that are involved there. But questions with any of this stuff? Okay, now I'm going to scroll down here because we got to talk about a couple other words. So some of the other stuff we have to talk about here. Let me scroll down. There we go. Okay. We need to talk about the base, obviously. When we talk about bases can be in multiple spots because, it's however what it sits on. But some people are like, oh, this is a base because, I could turn it over.
Yeah.
We call them faces. You can call them a base. I don't really care. We'll come back to this image here in a minute. But yeah, it's one of those things like you could put terms in different spots. Don't be thrown off by that. One of the things I want to give you the definition of right now, bless you. One of the things I want to make sure we go through the definition is called a regular polyhedra. Okay, that was the thing I said earlier. It's the most special type of polyhedron, right? Polyhedron, just straight edges coming together, right? Straight flat surfaces. But a regular polyhedron is when all of those faces are regular polygons. So what I'm telling you here is like the images I have on the board, these 2 pictures, are not regular polyhedron. Because do you agree that on this pyramid, the walls, these faces are triangles, correct? What's the bottom now? What's the base? What is this object down here, the base? It's a square or rectangle. Do you agree that those are different types of shapes?
Yeah.
That is not a regular polyhedron. To be a regular polyhedron, they have to use the same shape on every wall. So it has to be just a bunch of rectangles all connected. Or it has to be a bunch of triangles connected. It can't be any other shape. So like this picture is definitely not a regular polyhedra because it literally has a pentagon on the top, a 5-sided pentagon. The bottom's a pentagon, but all the other walls are rectangles. Not a regular. Regular has to be polygons that are regular. All the walls are the same, all the angles are the same, but they all have to be the walls. Every wall has to be the same picture. So there can only be select few types of polyhedrons that are regular because you wouldn't be able to connect them. So I'm going to show you the names here in a second, but does everyone understand that definition of what regular means for regular polyhedron? They have to be the same shape on every wall, and they have to be perfect shapes, regular shapes. All the walls are equal, all the angles are equal. So it's very, very specific. Alright, so let's go through the definitions here. Let's go through the types of regular polyhedra. Alright, so regular polyhedron, or the platonic solids, what the book refers to it as. It's any time, and this is the same definition you wrote down like 2 seconds ago, it's any time a polyhedron has regular congruent polygons on the edges. Okay, so here's the first type. There's 5 of them, by the way. First type is called a tetrahedron. A tetrahedron is a type of platonic solid where they're all perfect equilateral triangles. So, perfect triangle faces, there's 4 of them that are connected, so here's the picture. Now, what does that look like to you? Can you see that picture? Yeah, a triangular pyramid, right? That's what it looks like to me as well. But here's the weird thing. When you actually look at this picture, they tried to design this picture in such a way, there's 4 faces, 4 walls, and they're all the exact same perfect triangle. They're all perfect equilateral triangles. Does that make sense? Okay. It's kind of like a tip of a spear, or a tip of an arrow would be a tetrahedron. Tip of a pencil, when you get a golf pencil, they kind of shape it into that sometimes. If you have a triangular pencil. I've seen those before. They used to have those when I was a kid, triangular pencils. Alright, next, number 2, the second type, is a hexahedron. Hexa is literally the word for 6. So hexahedron has 6 square faces. So a cube, if you can see this, so square faces, this is what a cube would look like. Now, what does that object look like to you? Where have you seen something like that before? What object would you use that would look like a cube? A die, right? A perfect die. Okay, what most people don't know is a die is very, very mathematically engineered, so it doesn't matter how you roll it, every number is totally random. Some people complain, like, you know, the pits where the faces, like they've been carved down. They're like, well, the 6 has too many pits, so like the one side's too heavy. They're curved out in such a way that every wall is exactly the same weight. So it's perfectly weighted. So it's random when you roll it. Because it is a perfect hexahedron. There's 6 faces, and they're all perfectly balanced. You can tell weighted die, when you roll it, it will always go to the same number. They get pretty clever the way they design weighted die. You ever seen a cheater's dice before? They even make them where they look like they're see-through, where you can look and it looks like that green or red material, and like, no, it's see-through, so it's got to be a normal die. But what you got to notice is that when you put your hand behind it, you can't see your fingers. It's not actually see-through. They're messing with you, and it's got weights on the inside. What they do is they just move the weight from like the center of the die. They move it down slightly, so it's always going to land on this face every time. So the top number will always show up. Almost, it's like 99% of the time it will do that. So, but yeah, these are like these objects, a tetrahedron or a hexahedron. It doesn't matter how you roll it; it's fair chances for any side to happen. Now, obviously, we've been using triangles and squares, but they're going to continue using these because they can add more to it. So if I made another shape, we call it an octahedron. That's where you connect 8 triangles together. 8 equilateral triangles. Here it is. 8 equilateral triangles. This is where the square pyramid kind of comes in, where if you took away the bottom, it would look like a square pyramid. But it's actually 2 perfect triangles where all the faces are actually perfect triangles. Doesn't matter which way you roll it. Each face is totally random, coming face up. The next one, a dodecahedron. What does dodeca mean?
12.
12. It's got 12 faces, and they're all pentagons. Here it is. It's really tough to look at that one. It is a princess cut diamond, if you will. Where a princess cut diamond is kind of a roundish cut diamond, but all the faces are perfect pentagons. So the top is a pentagon, the bottom is a pentagon, so they're kind of like parallel to each other, and then all the faces going around. So there's 5 pentagons, and then the 2 tops and bottoms. But any wall is fair game. When you roll it, it will be totally random which one it would be face up. They're trying to show you like the dash, so you can see like the bottom of it, you can see through it. To me, that's really difficult. You're looking top down on that thing, as opposed to like the weird the octahedron where you're seeing it from the side. The dodeca, you're right on top of it perfectly. The last one, I can't even see this, like no joke. I can't even see it. I would have to physically hold the object. It is a 20-sided die called an icosahedron. An icosahedron is 20-sided and it's got 20 triangles. I'm going to show you the picture. This is what they show you. I can't see it. Like I can't see how that thing works. I would have to physically like hold on to it in my hand to see it. The best way I can describe it to you, it's the die that they use for categories. Categories, they take out a select few letters because no one wants to use a Z or a Q sometimes. So they take out certain letters on certain packs of the 20-sided die, so you're not using those letters. And so it's a 20-sided die. Any side is random. I can't even explain to you how to look at that thing so you can see all 20 triangles. I can't see myself. I'll try to bring one in tomorrow. Some people like who play Dungeons and Dragons probably have one. You can't make a 19-sided regular polyhedron. It's not possible. You can't make one. What time do band and cheerleaders going to go?
55 now.
1 minute. 1 minute. Okay, they'll probably come online here in about 10 seconds or 30 seconds. So get your stuff ready to go. All right. Now the last thing we're going to talk about is, because this is like one of my second to last slides, is if you're not a regular polyhedron where they're like perfectly designed. Ben, if you need to go, you can go here in a second. So, if they're not If they're not going to be regular, they could be the other shape. So here's my last slide.
It doesn't look like they're announcing it, so
That's fine, just go. Just go.
Band.
So band you should go to, if you need to. Okay? Alright, so the last few shapes for the polyhedron is how we classify them. This is my last slide, by the way. So the types of polyhedron, if they're not the regular ones, this is where they just be other shapes. The first one is called a prism. A prism is anytime you have a polyhedron, straight walls connected, no curves, nothing like that, but a lot of the walls are rectangles. They're like straight edges. So it's a polyhedron with parallel bases, and everything else looks like rectangles. So here's a picture. So it's got two faces that are perfectly parallel to each other. They call those the bases. And then everything else is basically a rectangle connecting them. The example that I always kind of show people is my little Kleenex box here. This is a prism. Okay, it's got two walls that are parallel to each other, the top and bottom, the bases, and then everything else is a rectangle connecting them. Now, how you name a prism is you just look at the two walls that are parallel to each other, top and bottom, and what are these objects called? Like, what is this shape? It's a rectangle, so this is called a rectangular prism. That's what you name it. You name it by whatever the base is. So in that picture on the board, the top and bottom are pentagons, so I call that a pentagonal prism. It's whatever the two walls that are parallel to each other, the bases. Now, the other shape that you would have is a pyramid. A pyramid is when it's not just perfect rectangular, it's when some of the walls come up to a point. Those walls that come up to a point have to be triangle faces. So a polyhedron that has a base for a polygon, but the other sides come up to a singular point because of their triangle faces. So here's my picture. Certain triangle faces come up to a singularity, a single point, and then the base is some shape. So now on this one, how you name a pyramid is you look at what the bottom is. What is this bottom on this particular picture? This is base. What shape does that look like to you? Square, so it would be a square pyramid or a rectangular pyramid, if you don't know if it's a square or not. So you just name it by whatever the base is. Now, obviously, those are what most people see as the different types of polyhedron. If you're talking about non-polyhedron, like curves, those are like the conics. There's different types of conics, the non-polyhedrons. Right? There's a cylinder. A cylinder is where you have two circles that are connected with a curved surface. So two parallel circles connected by a curved surface. If you were to take like a pop can looks like a cylinder. And this is really weird when you think about it. So you take a pop can, you cut off the top and bottom of your pop can, like somehow you remove the top and bottom, and you were to like cut straight down the pop can itself, the body of the pop can is actually a rectangle. The top and bottom were circles. So it is a curved surface, it just happens to be a rectangle connecting them. So it actually still follows the idea of a prism. Rectangles connecting parallel objects. That's a cylinder, right? It's curved. We have a cone. We talked about cones as a type of conic. You have a circle and you have a curved surface connecting the top. Okay? So, and it comes up to a point. That's a cone. And then the last one is a sphere. Sphere is where you have a singular point in the middle and all the points that are equidistant from it. Everything is equidistant from a central point. A set of all points equidistant. So here's your sphere. There was that was my last slide, by the way. There was this movie that came out in, like, I don't know, 2012. It's called Interstellar. You ever watch it? It was kind of a cool sci-fi movie. I really like the movie. But they had one of the greatest definitions of an Einstein-Rosen bridge, which is the idea of a wormhole. The idea that you could, in space, travel from one edge of space to the other edge of space almost instantaneously using a wormhole. And the idea is what they describe is like, imagine you're in space. Space isn't limited to, you know, there's no real gravity that holds things together in space. That's why objects in space are usually circular, spherical, because the only thing holding them together is the gravity at the center of it. That's why the human body, when it goes into space, number one, it freezes, but number two, it expands, because there's nothing really holding the body together. There's no real sense of gravity. So your body changes in space. And the idea is that a sphere is like when you're entering a hole in space, like a wormhole, the hole itself in space wouldn't just be a hole like you'd see in the ground. It would actually be represented by a sphere because the gravity is at the center of the hole, and it would actually represent as a perfect sphere, and that's what you'd enter for a Rosen bridge. Which I thought was one of the coolest ideas. Like, I never really thought about that. It took a sci-fi movie to actually explain the concept of, you know, why spherical objects are in space. It was just a really cool definition, how they explained it. I definitely recommend that movie if you haven't seen that. So, questions at all about our polyhedras and non-polyhedras, though? All right, we're done for the day. Pretty easy. That's all I want to do today, just talk about some words.